Good morning. My name is Daniel Casellas. I am the Scientific Director at the Eurecat Technological Center. It is a pleasure to welcome you to this seminar about the advanced characterization and modeling techniques for the sheet metal industry. In the last 20 years, I have been working in many research and development projects related to the sheet metal forming of high-strength steels, especially in the application of fracture mechanics to understand sheet formability and to estimate the fatigue and fracture of high-strength steels. So we know that high-strength steels change the sheet metal sector by introducing new materials with higher strength and outstanding mechanical properties, by developing new forming processes as the press hardening or hot stamping process, and also by inducing changes in the way that we characterize sheet formability. So definitely high-strength steels change the sheet metal sector, but also impacts in our life. Here in this picture, we can see the comparison of a crash test between two cars. The one on the right corresponds to a nowadays car, and the one on the left corresponds to a 20 years ago car in the similar segment. Clearly, the difference in the passenger safety, the difference in crash behavior, is related to the proportion of high-strength steels that we can see in the plots below the pictures. Now this car has about 60 or more than 60% of high-strength sheet materials in the body in white. We see here that high-strength steels and aluminum alloys play a major role in current cars, and they will be the dominant engineering materials in the body in white vehicles of the coming years. This is because they allow to construct lightweight structures in an affordable and a sustainable way. With increase in high-strength metal sheet in the European industry is increasing in the last years. Automotive and aeronautic sectors are driven this growth, mainly pushed by the constant demands on the high-performance parts for lightweighting. However, if we want a complete deployment of these high-strength materials, we need that the European industry can manufacture high-performance parts in an efficient and a sustainable way. And this is where the highest strength of these materials may be a problem. Here we see an industrial problem that is known as edge cracking. We will talk about this today. And this is an unexpected defect that happens during metal forming. So high-strength steels or high-strength materials in general can be considered as process-sensitive materials, which implies that forming parameters and the raw material quality must be carefully assessed to produce defect-free parts. The problem, I would say, or the challenge, is that these unexpected fractures cannot be predicted by conventional experimental techniques or by current modeling approaches. Then, as always, new materials bring new challenges. So today, in this seminar, the FormPlanet team will share with you the recent developments in advanced characterization techniques, in modeling, in process monitoring, and in materials intelligence to face these challenges that the metal industry is addressing. Before starting with the technical points of the seminar, I would like to show the today's morning agenda. We are now in the opening plenary with some technical speech and a keynote special invited speak. Have a coffee break, followed by two technical sessions. At 30:40 we have lunch break. We continue in the afternoon with two more technical sessions. Again, coffee break. And we close with a roundtable and the closing event of the seminar for today. Regarding logistics, you will see in your platform, when you are right now, you see the hall of the conference. In this hall, you have the info point, where you can click and you can have the agenda, you can have materials, we can have brochures, you can have scientific publications of FormPlanet, so please click it. On the link conference room, you go to the conference room, you go to the sessions. On the right, you have the networking room, click. You can click here and join a chat with the participants, with our speakers, and ask questions, of course, and give ideas, comments, and so on. And on the upper right part of the screen, you will have the menu to navigate through all of these options. What to do if you want to ask questions? So you have this bar in your platform. You can write the questions here. Please put the name and the speaker you want to ask. These questions will be gathered by our team and will be presented at the end of the technical sessions to each speaker. This is except for the keynote. For the keynote lecture, you can directly address the questions to the speaker just after the lecture. You also have buttons to join the networking during the conference. You also have a link and a phone just to contact our team in case of any technical issues or logistics problems. So at this point, it's time to explain and describe what is FormPlanet. So let me introduce you the project manager of FormPlanet, Begoña Casas. She has a PhD in material science from the Universitat Politècnica de Catalunya, UPC. She works as a researcher in the unit of materials technology at Eurecat and is manager of many international research and development projects. She worked for 10 years in sheet forming industry, so she has the perfect mixture of industry and R&D expertise to manage the first European testbed in sheet metal forming, that is FormPlanet. So please, Begoña, the stage is yours.
Thank you, Daniel. I'm going to give just a brief introduction about the FormPlanet project. This is an European project that with the aim of develop and validate an integrated ecosystem that is called a testbed to offer novel sheet metal characterization and modeling methodologies. This project has lasted 3 years and ended in December of last year to 2021. The FormPlanet, the consortium of the FormPlanet has consisted of 17 participants from 8 different countries, 3 technological centers, Eurecat, Fraunhofer, and Comtes, 2 universities, Luleå and University of Pisa, and 4 service providers, ANSYS Granta, UNE, AP+, Letomec, and 8 industrial partners, ArcelorMittal, Arania, Alludion, APNT, Arcelic, Lamera, and Stamp. Now we are going to project the FormPlanet video. Well, you will see summarized very well the main objective of the project.
Sheet metal forming is one of the most important manufacturing processes to obtain metal components for almost every industrial production sector, such as transport, construction, home appliances, and packaging. Generating over 500 million euros, this industry lacks adequate methods to assess sheet formability and part performance at the product design stage, essential to be able to develop high-performance parts at a reduced cost. To solve sheet metal forming industry's current challenges, the FormPlanet Open Innovation Sheet Metal Forming Testing Hub has been launched. Funded by the European Commission, we will offer to all kinds of companies in the sheet metal forming value chain novel testing methodologies and modeling approaches to improve the performance prediction of high-strength sheet materials and prevent production losses. This assures zero-defect production and the optimization of sheet materials development, manufacturing and performance. Thanks to FormPlanet, European companies will be able to access the services of 5 leading materials characterization centers from one place with equality of access and conditions. A one-stop shop service combining the technological experience of consolidated metal characterization sites and cross-cutting service providers to facilitate companies' technological uptake. With novel and differentiated material characterization tests, new modeling approaches, part quality assessment, and in-process measurements, materials informatics, incremental sheet forming prototyping, and support services. A boost to the competitiveness of the sheet metal forming industry. Contact us to learn about our service offer and how FormPlanet can help your company.
Now, after these 3 years of project, we would like to share with you the main outcomes and the main results of this project during this event. And I'm going to give you some facts very quickly. But during this event, you will have more information about the result of this FormPlanet project. In the first year and a half of the project, we have developed advanced testing methodologies for more accurate sheet metal characterization and non-destructive in-process measurements and modeling. These methodologies and modeling approaches covered the whole chain of the whole value chain of the sheet metal forming industry, from the sheet material development, also in the part and forming process design, to the components production. Just to give a very brief ideas of the services of the methodologies that we have developed in the project concerning sheet material development and production. We have developed solutions for example, for the edge cracking and stretch flangeability, for delayed fracture and hydrogen embitterment, also for fatigue resistant, fracture toughness measurements, micromechanical characterization, and crash worthiness determination. Concerning part and forming process design, we have developed solutions to evaluate the forming limits at room and high temperature, to modeling part performance, also to modeling hydrogen embitterment, to edge cracking and modeling and prediction also, and material data for modeling. Concerning components production, we have developed also in process check systems and inline part quality assessment. To validate and prove the effectiveness of these methodologies and modeling approaches developed during the first years of the project, we performed 12 demonstrators from different sectors and metallic alloys with industrial partners of the projects and also with the test sites. And this demonstrator covered all the value chain also of the sheet metal forming industry, sheet material developers, part makers, and end users. During the project, we have published 2 CEM agreements with the objective of standardize 2 novel techniques developed in the project. We also have developed, or ANSYS Granta, that is a partner of the FormPlanet, has developed a materials information platform on characterization with the help of all the partners. And we also have launched an open call during the last year to offer the opportunity to the companies outside the project to prove our services. 7 companies were selected in this open call from different countries, European countries, from different sectors. And finally, the most important outcome and challenge of this project is the creation of the open innovation test bed for characterization and sheet metal characterization and modeling. It will consist of a single entry point to access or to offer services from leading characterization organizations. And all this will be explained with more detail during this day. And I'll give the floor to Daniel to continue with the next presentation. And I hope you find interest in this conference. Thank you very much.
Thank you very much, Begoña. Now it's a pleasure for me to introduce the next speaker. Is Yanaris Ortega. She is the FormPlanet project advisor. Yanaris holds a PhD in physical chemistry by the University of Seville. She is the project advisor at the Health and Industry Executive Agency at the unit Industry. And she's currently managing European Union funded projects on materials characterization techniques. She will talk about the need of OITBs. Now, Yanaris will explain what this means.
Yes.
For metal characterization, EU policies, and funded research. So, please, Yanaris.
Okay, thanks a lot, Daniel. Is this mic? Yeah, this one. Thanks a lot for the presentation, Daniel. As Daniel just mentioned, I will present in the need of OITBs, EU policies, and funded research. So this is the points that I'm going to be talking about today. So I'm going to start defining what an open innovation testbed is, because that's our main topic today. So the Open Innovation Testbed is a set of entities which all together give and provide common access to physical facilities, capabilities, and services which are required for the development, testing, and upscaling. And all this is covering from the validation at lab till the industrial real environment. All this is done through a single entry point. And what a single entry point is a legal entity which is defined and established by the project in order to manage all B2B relationships. It means to give access to these facilities, capabilities, and services to the end users, to this one-stop shop. The OITBs is a kind of concept which is quite particular. It's not a common project. They are supposed to, on one side, to be sustainable after the end of the project. They have to test all these facilities, capabilities, and services, and also to create a sustainable ecosystem of enterprises, specialized enterprises. And also, they have to have open calls. And as Begoña explained before, these open calls is with the aim of testing these facilities, capabilities, and services, but also to test how this single entry point and these B2B relationships work. So what is the rationale for the OITBs? So the OITBs concept was born in Horizon 2020, at the beginning of Horizon 2020, with the aim of testing and validate new technologies which are essential for the commercialization. Also to give access to state-of-the-art technologies and infrastructures to any kind of entities with the objective of accelerate technology diffusion and access to markets, to emerging markets. As I said, to any kind of entities, but with a focus on SMEs and startups, which of course, due to the lack of resources, they are not able to afford the investment in this kind of infrastructures. So, as I said before, the OITBs will be bridging the gap between the lab and closer to market activities. So from TRL 4 to TRL 7, okay? And what is the added value for the OITBs and why it's so attractive for industry? And it's because they offer access to these capabilities and infrastructure. They reduce, and that's an important point, cost, but also raw materials and time to market. They harmonize the conditions for materials upscaling, characterization, and modeling, increase return on investment in materials, and also make easier marketability of products in Europe. So we have, at the European Commission, we have funded so far 8 topics with a total fund of 285 million, which have been allocated, as I said, in 8 topics, 25 projects. This is more or less the timeline for this portfolio of projects. 3 topics in 2018, that was the first generation of topics. Then 2018, 1 topic, and 2020 of 4 topics. All of them covering different expertise and different field of research. Okay, so as I said, the OITBs is a different kind of projects. They are more complex, they are bigger in terms of beneficiaries, but in terms of duration, but also in terms of contribution of funding. So on average, there are 26 beneficiaries. The duration is 49 months, and they have around 12 million of funding from the European Commission. Also, the composition of the consortia are quite special. And as you can see here in this chart, around 50% of the beneficiaries are coming from the private sector, and around 35 are SMEs. So that means that OITB concept has been able to attract industry really successfully. So this is the timeline, more in details on the OITB's project. The first one started early 2019, and it will be running till early 2026. The first projects from the first generation are finishing or about to finish now in early 2022, so we will be able to see concrete output in the coming months. So what's coming? So two main things. On one side, there is on the organization an OITB workshop. It's not organized by the European Commission. It's organized by the OITB projects themselves. So by all of you projects, so OITB projects ongoing or finished, but also industry or any kind of stakeholders that might be interested in this concept, in the services offered by the OITBs, are invited, because it's a good opportunity to give us feedback on which are the needs and which are the gaps that they still need to be considered for funding. And also there is a call topic. It's open currently in the Digital Europe program, and it's on the climate neutral and circular innovative materials technology open innovation testbed. It's a innovation action. The funding is 34 million, and the TRLs to be covered by the proposals is between 5 and 7. So this is the link. This presentation will be available afterwards, so you can have a look in the link that is in this slide. Otherwise, you can check it out in the Funded Under the Portal website. And this is the background information on OITBs in general, if you want to know more about the concept. And that's all from my side. I'm open to questions. I don't know if the questions are right now or afterwards. But
yes, thanks, Yanaris. The questions will be at the end of the session.
Thanks.
Thank you.
Bye.
Thank you very much for your presentation, your interesting ideas about the Open Innovation Testbeds. Okay, now it's time for our keynote lecture. It will be given by Henrik Sieurin. Henrik Sieurin has a PhD in material science from the Royal Institute of Technology in Stockholm. For the last 10 years, he has been at Scania Materials Technology, working with structural steels for trucks and buses. He has previously been working with the steel-related issues such as failure analysis, corrosion, mechanical testing, and welding for the offshore energy industry. He participated in many R&D projects about the application of high-strength steels in the truck sector, and he has a privileged view of how trucks incorporate the recent developments of high-strength steel sheets. So it's a pleasure to welcome Henrik to this keynote lecture. The lecture is about the sustainable application of high-strength steels for the electric trucks. So, Henrik, please, the stage is yours.
Thank you very much, and good morning, Barcelona. Thank you very much for that kind introduction and for the invitation to this this project conference. So I will today say a few words about our electrification journey with focus on my favorite subject, structural steel, and I will also say a few words about the environmental difference or the climate change potential with using battery electric vehicles and compare it with with a truck with a combustion engine and an ICE truck. So this is the overview of my presentation. I will first say a few words about Scania and our view of sustainable transports. I will introduce you to what structural steels that we use in a truck today and the demands that we will see and already have for BEV trucks. And finally, I will present some results from a recently finished comprehensive LCA study that we have done with a comparison between an ICE and a BEV truck. So our purpose at Scania is to drive the shift towards sustainable transport. As you know, the world urgently needs to break the correlation between increasing demand for transport and increasing carbon emissions. So therefore, we are researching, developing, and promoting sustainable solutions for cleaner and safer transport of people and goods. We are approaching a tipping point where the convergence of new technology and business models will result in a state where sustainable transport solutions will take off and become the new normal. And the current unsustainable solutions will be phased out. So the future of transport will for sure be decarbonized, clean, electrified, optimized, and digitalized. So this is a very short version of a long history. Scania was founded more than 130 years ago. In 1891, at that time, we produced railway carriages and bicycles, but the first car was actually produced in 1897, I believe, and the first bus in 1902, and the first truck in 1911. At 2020, we were about 50,000 employees in more than 100 countries. 2020 was, as you know, a turbulent year for all of us. Despite that, we sold products for approximately 12 billion euros and spent around 620 million euros on R&D. And we are still very proud to say that we have made profit every year since 1934. So our trucks are mainly divided into three segments. We have the long haulage, which is for sure the biggest segment, but we have also construction and distribution, and due to our modular system, we are very well equipped to also produce special need vehicles like fire trucks and garbage trucks. One growing business is, for an example, construction trucks for mining, which is a very flexible and way to, or an alternative to use big expensive dumpers. Using smaller construction trucks is for sure a smaller investment cost, smaller service costs, and lower fuel consumption. We also produce buses, both city and intercity buses. Traditionally, we have mainly produced chassis, but we are more and more producing complete buses. We also produce and sell engines, industry and marine engines. For an example, gensets for producing electricity, engines for agriculture, and ships and boats. One very important part of our business is the network and services, which include spare parts, maintenance, services like driver training and financing. And we actually also sell used vehicles, which is a strategic business due to, we sell trucks, and we also can keep maintenance in Scania workshops. So in order to let's see here, in order to, commit to our sustainable transport visions, and in order to in order to that it's not only some kind of buzzword for us, we have joined the Science-Based Target Initiative, and we're actually the first heavy truck or heavy vehicle manufacturer that got this approved. And our goal is actually even tougher, with instead of 2 degrees, 1.5 degrees. And with this, we will reduce our CO2 emissions from our own operations with 50% until 2025. And we have already, I think we have already achieved that goal. But since more than 90% of the CO2 footprint from our products come from the end user when they are used, we will also reduce the CO2 footprint from the end user phase, from when the trucks are driving, with 20% until 2025. And we expect that in 2025, 10% of our sold vehicles in Europe at least will be electric, and by 2030 in total 50% electric vehicles. So these climate goals are really complex challenge for the transport sector. And these carbon law, a little bit simplified, say that we will halve our emissions every decade. So this is something that we have to fulfill. So when will electrification happen, and in what applications? Well, this will happen much faster than we thought just 2-3 years ago. I think there are three reasons for this. Number one is the demand for sustainability from our customers as well as from ourselves. The second reason is cost. The total cost of ownership for an electric truck will be lower compared to an ICE truck. And then we have the technical part. We already have batteries and as well as charging, although of course we need to build a better charging infrastructure. So as already mentioned, at 2025 we expect around 10% electric vehicles, and by 2030 around 50%. And in 2030 we expect that more or less all applications can be driven electric, but of course it might not be an economical feasible solution for all customers and all applications. So I will now smoothly go over to my favorite subject, which is structural steel. We for sure see some demands when loading the truck chassis with hundreds or maybe even 1,000 kilowatt hour of batteries. Number one, batteries are big. We need to have a slim chassis in order to fill it with as much batteries as possible. And for this, we need high strength material and advanced or state-of-the-art forming technologies. Batteries are also heavy, and in order to keep or maintain a satisfactory load carrying capacity, we need lightweight. In other words, we need high strength material. Batteries are also expensive, so we can't afford any fancy expensive material solutions. And batteries are sensitive, so we need to protect them from crash. So we need high strength material again with good energy absorption. We see a lot of mixed material solutions as well, and joining of these are a challenge. So, I mean, to conclude this slide, I would say that projects like FormPlanet is highly relevant, and that R&D regarding high strength steel and advanced forming technologies is still highly requested. Let's see what steel that we use in our track today. If we start to look at the chassis, we mainly use hot rolled steel between 3 and 10 millimeter. It's mainly thermomechanical rolled steel, typically 355 MC or 500 MC or even 700 MC. We do use some press hardening steel also in the chassis for crash protection, for the bumper and the underarm protection. And for the chassis, it's most often fatigue that is dimensioning, but also, of course, there are stiffness requirements, corrosion, etc. On the other hand, if we look at the cab, here we see really similar materials as we see in passenger cars, with similar thicknesses between 0.8 up to 2.5 millimeter. The panels are usually interstitial free steel. Here it's difficult to gain anything by using more high strength materials, since it's the stiffness that are dimensioning really. Here it would be nice to have some, thin material with high stiffness, like a sandwich material or something like that, or at least low density. But on the other hand, we need to have really nice surface finish. So that's a challenge. For the structure, we see high strength, low alloyed steels, DP steels, and press hardening steel, just as in the passenger car. And the sheets are galvanized, mostly hot dip galvanized, some electro galvanized as well. And the requirements for a cab is also rather similar to a passenger car, but with higher demands on fatigue, I would say. But yeah. So with our last cab generation that was released in 2016, we reduced, I think, around 10 to 15% of the cab by introducing advanced high strength steel, which was not used previously. We use a lot of roll formed high strength profiles in DP600, DP1000. We also have some press hardening parts like the A-pillar and this beam under the window. And the introduction of advanced high strength steel has also forced us to introduce some new joining technologies like laser bracing and adhesives. And as I said, in the chassis, we also have press hardening steel, relatively thick press hardening steel between 2 and 6 millimeter. So just a few thoughts about lightweightening. This can be obtained by obviously reduce the thickness of the material. In other words, using more high strength materials. We can reduce the density by using, aluminium or magnesium or polymers, composites. We can also use sandwich materials, which I here have exemplified by this Hybrix sandwich from Lamera. I know that this material has been investigated in this project, and we at Scania has also produced some nice demonstrator parts with this material. We can optimize the geometry using topology optimization. This the result from this usually is geometries that for sure need formable materials. So sheet material with good formability is required. We can also use function integrity. That could be, for an example, filling a side member or a cross member with batteries, and in that way that the component be both a structural part and the battery box. I will focus a little bit more on the reduced thickness track, which then can be achieved by using advanced high-strength steels. But for chassis components, there are some issues. As I mentioned, it's the fatigue properties that most often are dimensioning, and it's unfortunately not a linear relationship between yield strength and fatigue strength. In order to enable the use of more high strength material, we need, first of all, we would need, we would like to see further development of hot rolled grades, maybe with focus on fatigue properties. And I know that, there are many interesting projects ongoing in order to understand the relationship between microstructure, fracture toughness, fatigue properties, and hopefully we can learn from this and design new hot rolled steel alloys optimized for fatigue properties. Another way to enable more high strength material is to focus on the edge and hold qualities. We need, if we have a bad edge quality or a trimmed edge with small micro cracks, there's no point in increasing the strength of the material. It might even worsen the fatigue properties. So I have here exemplified this by using this two-step punching or pre-piercing of holes, which is one way to achieve better surface qualities and enable the use of more high strength material. And then, unfortunately, more or less all steels have the same E modulus. So when reducing the thickness, we might get stiffness issues. This can be solved by using, for an example, patchworks or Taylor rolling or 3D roll forming, for an example. Okay, I will now move over to this LCA study, where we study two reference vehicles, one ICE, one BEV, from cradle to grave. They are really similar except for the engine and driveline. We assume that they will drive 500,000 kilometers with an average payload of 6 tons. And we have also assumed that we have no reuse of the battery, so the full production burden is attributed to the vehicle life cycle. So you could say it's a conservative way to think. So first of all, let's take a look at the bill of materials for the two reference vehicles. As you see, in both cases, it's about 50% steel, very steel intensive. And of course, one difference is that in the BEV, we have, in this case, around 13% battery cells. This will most likely increase when we increase the range of the vehicles. This reference vehicle has a driving range, I believe, about 250 kilometers. But I mean, in just a few years, we will have 500 kilometers. So this will increase. So if we then look at the greenhouse gas emissions from the vehicle production, the BEV will have almost a double amount of greenhouse gas emissions from the production phase. For ICE, almost 50% come from the steel production. But for the BEV, on the other hand, the main part comes from the battery cells, which is due to the electricity used for producing the cathodes and anodes. They are today mostly produced in China with a rather bad electricity mix, but this is something that we need to focus on. But as you can see, steel is number 2, and these, I mean, tell us that we need this fossil-free steel production as soon as possible in order to reduce also this part. So this figure shows the climate change potential. For this study, you see the CO2 equivalence on the y-axis for the ICE and for the BEV. As already said, the production part is worse for the BEV. Then we have the use phase is divided into well to wheel and wheel. No, let's see. Use well to tank and tank to wheel. So for the ICE, we have a really big impact for, I mean, from the tank to wheel, I mean, the combustion of diesel. For the BEV, on the other hand, we have a higher part for the well to tank. So this is due to the electricity mix that we use for charging the batteries. But as you can see, there's, in this case, and here we have used the 2016 electricity mix in Europe. So here we have a 38% reduction with the BEV. But it's really the electricity mix in the use phase that is the most important parameter. Here we have looked at some other scenarios. I mean, if we see a continued reduction of fossil produced energy, we expect that in 2030, we have a 63% reduction for the BEV. And if we assume that we can charge the battery with pure wind electricity, there is an 86% reduction. But what we have left and work with for is the production phase then. And then if you remember, it's we need to have green electricity for battery production, and we need fossil-free steel in order to, be, well, with that, we will be well below 90%. So when do we see a break even then? The BEV has a higher environmental impact from the production. Here we see the different electricity mixes and the ICE. But already around 50,000 kilometers, that is about 1 year in use, we can see a break even, which is pretty good. And finally, I come to the conclusions. I think I'm in pretty good time. So with sustainable battery production and fossil-free steel and green electricity for charging the batteries, the greenhouse gas reduction potential for BEVs will be more than 90%. And for load carrying capacity, battery protection, we will need advanced high-strength steel with good formability. And the amount of advanced high-strength steel will continue to grow, as I see it being the sustainable material of choice, considering recyclability, which of course is a very important issue. Strength, cost, joinability, predictability, and so on. But I thought this was going to be my first presentation in 10 years without the steel banana, but I managed to squeeze it in on the last slide, just to emphasize that we, as well as all other automotive companies, have a high interest in, of course, in high-end this banana curve. And for an example, these quench and partitioning steels are very interesting, both for crash protection, for the cab mainly, but it might also have satisfactory fatigue properties. I don't know. I've seen both good and bad results there, but it's an interesting area, obviously. So that was my last slide, and there are, I think, 3 minutes for questions.
Thank you very much, Henrik. It was a really interesting presentation. It's always nice to hear your ideas, your how the truck sector is moving in lightweight construction. Thanks. So we have time for some questions. So you can also address it through the chat if you want. Henrik, I would like to start with this questions. Okay, you perfectly show that the lightweight construction in heavy-duty vehicles, it's different than cars. In trucks we need higher fatigue resistance, combination of toughness, stiffness, and so on. And chassis is really an interesting part to lightweight, because it accounts for about 20% of the truck weight. So I think that is really interesting to address efforts in this part of the vehicle. You show in one of your slides that the batteries will be held on the chassis, and as you perfectly said also, this will put more fatigue and mechanical requirements on the chassis. So I guess it's a lot of possibilities for lightweighting in this part. But chassis are sensitive to fatigue, to the forming processes, are sensitive to the effect of the material quality and the processing. So how do you think that the sheet manufacturing sector has to be adapted, has to be prepared to produce this sheet materials part for the chassis, considering that they are thick and they are process sensitive? What can you recommend for our attendants from the sheet metal sector to be ready for this new demand from the truck sector?
Yeah, that's a good question, well, I think, as I think I mentioned, I would really like to see further development of advanced high-strength steel, also for slightly thicker dimensions. I mean, for cold-rolled thin materials, there is. I mean, the automotive industry is really strong and pushing this development, mainly with focus, or quite often with focus on energy absorption and crash protection. But for truck chassis, we need slightly thicker dimensions, and it's the fatigue properties that are most often dimensioning. So I think it would be very interesting, or it is very interesting to follow what he's doing with designing complex phase steels with focus on fracture toughness and fatigue resistance. And also we have these, the machinability, punchability, etc. If we can produce, we don't on a sheet chassis. I mean, we don't have machined surfaces like in an engine, or for an example, where you have really smooth surfaces. We do have engineering surfaces, or whatever you can call it. So that's also an important aspect. Yeah.
So definitely, it's interesting times are coming for the steel. And
it is, and as you say, I mean, this electrification we are talking about several tons of batteries to be mounted. I would say mostly on the chassis. That will, locally increase the stresses in chassis components, so that they need to be stronger. But on the other hand, we can't lose too much load carrying capacity. We can't, only drive around and transport batteries. It would be nice to transport some goods as well.
Yep. Yeah, in this, you mentioned the application of complex phase steel with higher fracture toughness and higher fatigue. So the first question coming from the audience is from the steel sector. It's addressed by Eiso Atsema from Tata Steel. He's asking you, Henrik, how do you see the applicability of complex phase grades? How do you see the applicability of nanoprecipitate steels and dual phase that the steel sector is still offering?
Yeah, when we considering shifting to a more high strength material for a specific component, again, it's we have to know the fatigue properties of the material, and for these high strength materials, we see quite different results depending on the microstructure, whether it's a complex phase steel, a nano-precipitated steel, etc. There is you see huge difference in fatigue properties, and I for sure see a future with more, advanced high strength steel also for the chassis. But the big question is, what kind of steel, what kind of microstructure is the most feasible? I know that there are, these complex phase steels looks quite interesting, has been shown in many studies, for an example. But I see a future for this kind of steels for sure, but it's still an open question what material that will be the best. When designing a chassis component, obviously we would like to design it in a way that we have high stresses in the plate field, not in the edge, because then the benefits with the more high strength material we will not have. But if we design it in a way that we have high stresses in maybe a radius in the sheet material, there is a possibility to take advantage of a more high strength grade. So I know I'm looking forward to the further development of these grades, also above 3 millimeter, between 3 and 8 millimeter.
Yeah, in this direction also is still asking or proposing that maybe for fatigue dimension in parts, the effect of the cutting edges is more relevant, the base material fatigue itself. So I think that you are an expert in this, and I think that you also show in the presentation, right, that the fatigue sensitivity is really important for these steels.
Yeah. You could also consider, to use, shot blasting, shot peening, even for sheet material. Maybe you don't have to do the whole part. Maybe you could do it locally to tailor it. And it's the same thing with this, using this pre-piercing or two-punching of holes. You don't need to do it on every hole maybe, but you on the specific places where the stresses are high. Yes. And, so there are other ways to come around it using this kind of technologies, blasting, peening, two-step punching, etc.
Exactly. This is maybe advice for the sheet metal manufacturers to combine material and forming processes. So the last question from the material science comes from one of our FormPlanet members, Alludium. Carlos Pardo is asking if you are considering using aluminum alloys for the batteries, for the battery cage.
Yeah, aluminium is, I think, the most common material for these applications still. It's definitely a suitable material in many cases. Although I think that high strength steel could also be an option. But I definitely, aluminium. We will see. I believe personally that the amount of aluminium will increase, mainly in battery box.
Cage,
Cost aluminium, maybe mainly.
There are some other questions that we can address to the chat about other materials, stainless steel, quench partitioning. So very interesting questions that you can address to the chat. Thanks, Henrik. It has been a pleasure to have you here today, virtually. Next time, of course, presential, please. And also thanks for showing us the steel banana diagram. It seems that it will never die. In the last 20 years, it has been always present, but maybe it's going to the end. In the FormPlanet, as you know, we develop an alternative diagram to banana that maybe will beat them at the end. So thank you, Henrik. So please be ready on the chat for answering our attendance questions. Thanks.
Thank you very much.
So let's move to the next presentation. This is about the FormPlanet, the sheet metal forming testbed itself. It will be done by Eduard Piqueras and Laura Arribas at Eurecat. Laura will be our first presenter of this part. So Laura is industrial engineer from the UPC. She worked in the technological consulting department at Eurecat. She has a long expertise in coordinating and participating in projects working with innovation ecosystems. So Laura, please.
Thank you very much. Good morning to everybody. This is Laura Arribas, and together with Eduard Piqueras, I will be presenting this FormPlanet testbed. Okay. So we will give a quick overview of what the FormPlanet testbed is, who is behind FormPlanet. We will also be talking about the offering of FormPlanet, how we did this service validation of the services offered by FormPlanet, and finally we will talking about the official launch of this testbed entity and the materials available online. So, what is FormPlanet testbed? FormPlanet testbed is an open innovation testbed offering services which are the most innovative sheet metal characterization, modeling, and quality testing. I will not be entering on what an open innovation testbed is, because Yanaris explained before that, but just to let you know that during the project we've been working as open innovation testbed ecosystem in a collaborative way by using in the framework, let's say, of a consortium agreement. But now that the project is over, we need to move on, and we believe that the services and the work that we've been doing needs to be continuously done, and we will be creating a new company to provide those services to the industry. I will explain later on, well, my colleague Eduard will explain later on when it will be done. But for the moment, just let you know that FormPlanet testbed is key for the industry of sheet metal forming, because it will facilitate, or it is facilitating, let's say, the company access to the sheet metal forming and sheet metal characterization, modeling, and quality testing services, which are really advanced for the industry, with offering a full service package along the whole value chain of the sheet metal forming industry. There are a lot of benefits of creating this testbed. The first of all is the access to valuable technology services. In Europe, there are a lot of capacities really that are advanced, and they are not well known by the industry, and in this way they are not accessible for them. So FormPlanet wants to merge all these capacities all together by using a single entry point to offer them, so that all the companies in Europe can easily access to those capacities. These services will be provided in fair and equal conditions to all the industry, so not only there will be no differences between countries. And the service portfolio has been designed in the way that it takes into account all the type of companies that will be using it, so to say both SMEs but also large companies. Considering the SMEs, we know that they cannot afford all the services, so mainly the ones that are more expensive. That's why we've been designing the most expensive services in the way that they can afford them in a modularity way. And finally, we want to say that this Open Innovation Testbed, which is FormPlanet, will be providing an integral service portfolio, not only these novel services, but also the services that are complementary to this service portfolio, so that the customer can access to the whole service picture, let's say. Talking about who is behind FormPlanet testbed, in the project there were, Begoña told you that there's been a lot of partners in this consortium, but now that the project is over, we need to move on, and this new entity that will be created in few months counts with 3 main research partners, let's say, in Europe, which are Eurecat, based in Spain, Comtes, based in Czech Republic, and Letomec, based in Italy. These 3 main partners, for the moment, will be the shareholders of this new entity that will be created to offer this service portfolio that I will explain later on. Of course, this is not closed. We are, as I was saying, in the process of creating this new entity, so we are still working on the, let's say, the collaborative agreements between the partners and also among us. So, well, we are open to any proposal still. Which is the offering of the testbed? As I was saying, the offering is based on these novel characterization services that will be provided. But also it will account on the complementary services to provide this full service offering to the companies. The novel characterization services are mainly advanced testing methodologies that tackle working on the more persuading this sheet metal characterization and destructive in-process measurements and modeling. And they are addressing all the challenges in the sheet metal industry. This service portfolio has been designed considering the different value stages of the value chain to facilitate the understanding by the customers. In this sense, we've been identifying the sheet materials development and production as value chain, part of the value chain, also the part and forming process design, and also the components production. For instance, for the sheet material development and production, we have the edge cracking and stretch flexibility, the fracture toughness, and the crash-worthiness. For the part forming and process design, we have the forming limits evaluation, also the modeling of age embrittlement and the material data for modeling. And finally, for the components production, we have the in-process check systems and inline part quality assessment. As for the complementary services, to give this big service portfolio and full service offering to the companies, we have also other materials characterization services that will be provided in the framework of the testbed, and also consultancy and training services. All these services, mainly the advanced ones, will provide really differentiated benefits with respect to the existing methodologies in the state of the art. For instance, they are working towards ensuring zero defects production, to develop of new performance sheet materials at reduced cost, also to reduce time to market and work towards developing new high performance sheet metal parts at reduced cost. Also working towards increasing the productivity and of sheet metal parts, to improve quality parts, and also to build robust processes. These benefits have been tested during the project, and my colleague Eduard will explain it later on in a few minutes. But before that, we want to share with you the FormPlanet video on the testbed.
How can you achieve the production of zero defects sheet metal products with the many challenges standing in your way? Difficulties to assess sheet formability, non-expected part performance, and production losses due to cracks are just a few of the obstacles manufacturers deal with when launching new products and materials into the market. FormPlanet Testbed empowers the sheet metal forming industry's competitiveness. Working with us means having access to a one-stop shop, providing integral advanced metal characterization methodologies, non-destructive in-process measurements, and modeling approaches to assure a zero defects production and optimized sheet material development, production, and performance. Our services, offered by leading research and innovation entities across Europe, provide market solutions to your current industrial challenges. Whether you are a small, medium, or large enterprise, you can benefit from FormPlanet Testbed with equality of access and conditions. As your innovation partner, we will help you by increasing productivity, improving product quality, optimizing processes, and cutting the time to market for your future high-performance metal parts and products. FormPlanet Testbed, fostering advancement in the sheet metal forming industry.
So after this video, I give the floor to my colleague Eduard Piqueras, which is the project coordinator of FormPlanet.
Hello, good morning, Laura. Thank you, Laura, and thank you, Daniel, for the introductions. And good morning to everyone, to all the audience. Nice to have you all on this event. Unfortunately, I could not join our team presentially today due to some COVID around me at home, but it's good that I can join it remotely. Well, as Laura presented, and also my colleagues Daniel and Begoña this morning, FormPlanet aims to be this single entry point or to address these new challenges coming from these new material needs in the different sectors using sheet metal. Okay, the idea is that behind FormPlanet you will find knowledge, technology, facilities, laboratories, okay, experienced researchers and specialists in sheet metal that will help you in addressing all these new challenges that have been presented and discussed during this morning. Okay, what we made during the FormPlanet project is developing these new advanced characterization and modeling methods. Okay, and now the main outcome of the project, apart all the other relevant results, is to setting up this new entity Okay, these new single entry points, these doors to the industries working with sheet metals to solve all their challenges, future challenges, as we hear that they will come on trends regarding the electrification in automotive, but also many other challenges regarding materials that are addressed in other sectors. Okay. Yes, well, as Yanaris as our project officer, Yanaris Ortega presented this morning, there are several open innovation test beds running nowadays. FormPlanet is one specifically dedicated to the characterization and modeling of sheet metal, and it's one of the first open innovation test beds. I would say that I think we are the first open innovation test bed project finishing this year. So I think yes, we will be the first one establishing this kind of new entities. Okay, Laura, you can go to the next slide. Okay, all these new advanced characterization and modeling methods that were developed during the project to address main material challenges, mainly to predict material and part performance when working with new advanced materials, advanced high-strength materials, but also aluminium, multi-layers, and other kind of sheet metals. All these new methods, their main objectives were to address the problematics when using these new materials, regarding mainly on rejected parts, but also these rejected and cracked defects, for instance, they all bring to cost-consuming, time-consuming. Okay, when developing new materials, developing new parts. Okay, so there were this need on characterizing and predicting behavior of materials, right? We developed this research level, but it was important to see how these new methods and new modeling approaches really serves the challenges that the sheet metal industry is addressing and will be addressing in these new trends on the sector. Okay, that's why we make a validation of these services during the project to really validate and see how the effectiveness and reliability of the novel testing methods developed during the project. Okay, our goal was to optimize the production of new sheet materials, advanced high-strength steels, but also aluminum alloy, multi-layers, and other metal alloys that are involved in the sector. Okay, cold rolled steels as well, to help on this part and component formability and behavior prediction. Okay, for this reason, we make the following plan. Next slide, Laura. We first of all we had on our consortium, on FormPlanet team, there were eight FormPlanet industry partners. Okay, that the intention that were covering the whole value chain of the sheet metal. That means that there were one representation of industries producing sheet metals. That it's the column on the industries on your left. ArcelorMittal, a steel producer, mainly for different sectors, and very known for automotive steel provider. Arania, producing cold rolled steel for automotive sector. Lamera, producing a multi-layer material that previously Henrik from Scania was mentioning that it's an advantage when looking for low density materials. Okay, and Alludium, producing aluminium and another solution for looking for low density materials. Alludium working with sheet aluminium for automotive, but also for other sectors like cosmetic packaging and beverage. And from the other side, on your right, to complete the value chain of the sheet metal, there were those industries using sheet metals to produce advanced parts and advanced products. Okay, in this part we have a representation of different sectors. A big part is of the challenges in new materials, as we have heard in the beginning. It's on our automotive. In this sense, we had CRF, the research center of Fiat, Stellantis Group, STAM, also working in the automotive, and AP&T. Okay, also we worked on home appliance sector with Artelic, a part maker in this sector. Okay, we applied the methods and models to different real industrial cases on these industries. Okay, and what we measured also is how these new methods benefit these industries. Okay, in terms of less rejected parts, less rejected material, less reducing the time to market of new materials. Okay, reducing the costs associated for rejected parts, etc. Okay. After this, on the second year of the project, we made this, and after this, next slide, Laura. What we make is to launch an open call within the project. Okay, the open call had two main goals. From one side, we wanted to test how these B2B relations of the single entry point will be handled. The operational of the Open Innovation Testbed, acting as a single entry point for industries looking for help in solving their challenges. And from the other side, we still go forward on validating and measuring the benefits of the new characterization and modeling methods. Okay, that's what we have been doing with our industrial partners from the project consortium. We continue doing with these 7 awarded industry use cases from the FormPlanet open call. The open call, yes, we selected 7 companies from 14 applications. These companies received services, the services that the Open Innovation Testbed will offer. And yes, we tried to, we get different companies working with different materials and also different sectors like transport, automotive, but also machinery, manufacturing, and home appliance. Okay, next slide. Okay, once we get this first validation with industrial partners from the consortium and second validation with companies from the open call, we get sure that this new characterization methods and modeling brings important benefits to those companies developing new sheet metals and working with new sheet metals for developing advanced parts and components. Also, we tested the operative of the Open Innovation Testbed. So now this is all ready to officially launch the first Open Innovation Testbed in materials in sheet metals characterization. Okay, the new entity it's now ending the last adjustments to be legally established. So it's expected to be created by in the middle of this year. Okay, but nowadays, FormPlanet is already working as an Open Innovation Testbed. So you companies can just already ask for help if you to solve the material challenges. The Open Innovation Testbed is running, it's working, and despite it's not legally constituted, but you can consider it's working. You can go to our website, follow us, ask for help, ask for advice. You have our service catalog, detailed service characterization and modeling service catalog. You can take a look there, ask questions, etc. So yes, this conference acts as an official launch of the first Open Innovation Testbed for sheet metal characterization and modeling. So that was all I wanted to say you today. Yes, thank you very much for attending and for listening, and feel free to ask questions. We are here for this.
Eduard, Laura, for introducing us what FormPlanet is. So you said, Eduard, that FormPlanet is already launched. I mean, that interested partners can contact us to learn more about what FormPlanet can do for them. So please go ahead in that. The time is running. I mean, we are at the coffee break time. Questions to the presenters for this session, please address through the chat. We will immediately answer you. So yes, this is the closure for this first open and plenary session of the seminar today. We come back at 11:10 after the coffee break, where we start with technical sessions about the first one will be innovative multi-scale metal characterization techniques. So a lot of new developments of metal characterization and how we can address the challenges for sheet metal forming of high strength steel. So let's meet in 20-25 minutes. Enjoy the coffee break. Thank you.